So, good evening, students. This is about yeah, this is about the numericals. So here the numericals part for gate basically for most of the common branches consists of three parts. So they are like this. So numerical first one is so numerical solutions to equations. Here I mean equation means uh, algebraic or transcendental equations. That is the first part we are about to discuss, and then followed by uh, followed by numerical integration techniques, numerical integration techniques, and then followed by we have the third one. We have the third one. The third one is numerical solutions to ODE. Numerical solutions to ordinary differential equations. These are the topics uh, which comes for a gate examination. So, when we come to these numerical solutions to equations, so when we discuss about equations, you have usually see something like you have f of x is equal to 0. So this is an equation. You have in the left hand side the expression part and the right hand side is a 0. So a solution here I mean any number a, any number a, real number a, such that f of a is equal to 0 is known as a solution to this equation is known. So in such a case, then we say that a is a solution to the given equation. And now see, and also sometimes we call this one as a root. A is also known as a root of the equation. So a is also known as a root of the equation. So if you draw the seed, what is the geometric meaning of that one? So if you if you draw the graph of y is equal to f of x, see, remember we are looking for solution to f of x is equal to 0. This is the equation. Now try to draw the graph of y is equal to f of x. So you have here x-axis and y-axis. If you draw suppose a graph like the graph of f of x looks like this, or see it may appear like this also. We are see something like this. It may appear like this. So in such a case, see for example, what I like to see, one can observe that. See, this if you treat this as y is equal to f of x, then what is happening at this point? See, there is some point. Let it be a comma 0. At this one, f of a is 0. Y is 0 here. That's why f of a is 0. So this is in fact the root of that equation. Root of that equation. Uh, that is the thing. So, and see what is happening here. We knew very well that one can easily see that if you look at this C here like this, it is coming and it is going like this. See, in this one, in this part, y is positive. Y is positive. Once A crosses from left to right of A, if you reach, then f of x becomes negative. So there we can say that, see that a change in sign is noticed at the point of A. If you look at, if you consider this as our y is equal to f of x graph, y is equal to f of x graph, then you have two things. This is one and this is another one. Okay, so there are two roots here. There are two roots here. So if when there are two roots now, when there are two roots now, see if you look at this place, see from when you are moving along x-axis from left to right, from left to right, once you till here, till this point, the graph is here, so y is negative. Once it crosses this so-called root or solution to the equation, then in this part it is always positive. It is always positive. So, and again this will become, it will become a root, because at this point also f of x is 0. So from positive to negative you are coming. So what is happening is that when a is a root of f of x is equal to 0, then you can notice a change in sign at a change in sign at a for f of x, for f of x. That is most important observation. That is most important observation. So what happens then is that, now see, whether you are at this point or at this point. Suppose for example you take this as your y graph, y is equal to f of x. Then if you are at this point, when then you may be at this point or at this point. Okay, fine. But if it is at this point, see, you take any point here. You take any point here and here, some 2 points here. So what is happening here? At this point, f of x is negative, and at this point f of x is positive. So f of x into a product of these two things is always negative. If you take this point and this point, similarly here also you can observe that f of x is, if f at this point into f at this point is negative. On the other hand, if you take these 2 points, it is positive. So what we can notice is that, suppose, there is an important observation here. The important observation is that, see, if f of a into f of b is always, see here, is less than 0. If it is less than 0, then there is a root. There is a root for f of x is equal to 0 between a comma b. Notice that we are choosing a and b such that we are choosing a and b here such that, see, uh, here a comma b are such that, a comma b are such that fa into fb is less than 0. Fa into fb is less than 0. So right. So this is what exactly happening. So to determine the root, to determine an approximate root, now you can see there is a root between a and b, one can say. So now see, when it comes to this finding root, approximate roots we are discussing, that is about numerical solutions to uh, yeah, equations. Then we have four methods. One is known as bisection method, the another is known as regular falsy method, the third one is known as Newton-Raphson method, and the fourth one is fixed point method. So quickly, if you go to this, so this everything I have discussed. See, bisection method means simple. You find two numbers A and B such that A is less than B and f of A into f of B is less than 0. Then an approximate root of that equation f of x is equal to 0 is given by A plus B by 2. That's an approximate root, it says. When it comes to fixed point iteration, so see here, when it's a bisection method means we are here actually. So if you are able to find A and B such that A is less than B and yeah, are such that here there is a change. Here they are such that A is less than B and f of A into f of B is less than 0. Okay. So in that case, we can say that an approximate root, in that case, an approximate root to the equation, to the given equation, to the given equation. What is the given equation? To the given equation, f of x is equal to 0. Okay, is x star, I say it approximate root a plus b by 2. This is the idea behind the bisection method. Then once this x star is determined, then you please check whether fa into c. Then what we need to do, once that x star is determined, just check the sign of fa into fx star. If this is C, if this is less than 0, if this is less than 0, then the next approximation, that is the best approximation, that the current approximation will be updated as A plus x star by uh, 2. Okay. Otherwise, or else, the approximate root is x star is equal to x star plus b, the other part of the interval. That is what. So this is bisection method. This is what we mean by bisection method. Then comes the what they call something like yeah, okay, we follow this PPT. If we follow the order in which the things were presented in this PPT, let me see. Yeah. So the next one is false position method. In this one, see, so this one is what I explained here is, what I explained here is, this is bisection method. This is called bisection method. This is called bisection method. Now we go for the next method, that is called false position method. So it is called false position method. So in this case, see how the false position method is explained here. We'll go for that. Yeah. So here in the false position method, you have see, okay, right. In the false position method, you have xn plus 1 is equal to, I'll tell what we mean by this, xn minus 1, okay, xn minus 1 minus of xn minus 1 by fn minus 1. I'll explain the notation. Fn minus 1. Right, this is the formula. I must explain what we mean by this xn. So, first of all, from where this n will take values. So, n takes values from 1, 2, 3 like that. Okay. So, if you put take n as 1, what the above thing is becoming? So, is x3 is equal to x1 minus, see here, is equal to x1 minus. Okay, because we are taking, sorry, x0 minus x0 minus. So we have uh, x1 minus x0 by f1 minus f0 into f0. Right. So see here, what is x0? X0 is called initial approximation to the root. See, always remember one thing. The given equation is this. The given equation is f of x is equal to 0. The given equation is f of x is equal to 0. So uh, now see what is x0? X0 is initial approximation to the initial approximation to the equation. Initial approximation to the root of the equation. I mean given equation. Then what is x1? X1 is the another, that is a first approximation. First approximation. These two things uh, we must know. Okay, we must know, etc. Then the second approximation can be found by making use of this. This formula. So sorry, here it is 2. Second approximation can be found like this. And if you want the third approximation, then see we have x0, x1. How can we find x0, x1? You just simply choose, as in the bisectional method, simply choose two numbers x0 and x1 such that x0 is less than x1 and f of x0 into f of x1 is less than 1. So then you are not saying that the next root is x0 plus x1 by 2 as claimed in the bisection method. We are saying that the next root is x2, which is given by this formula, and one more thing, one more thing here, what we mean by f0. Here f0 is f of x0. Instead of writing f0, f of x0, we are writing f0. f1 means f of x1. Likewise, so you can find, once you determine x0 and x1, you can find x2, and once x2 is determined, then we compute f of x2. So that is nothing but f2. So you can get the third approximation as x1 minus, okay, x2 minus x1 by f2 minus f1. See here, f2 minus f1, okay, into f1. Into f1. So the so I already described how f1, f2, f3 are defined here, f0. So we found x3, and like that we keep on continuing this process until two successive approximations, the absolute value between the absolute difference between the two successive approximations for this root is less than the specified error, less than the pre-specified error. So this is what we mean by secant method. So this all got, we got the this idea, we got this idea from the secant line. That's why this is known as secant method. So the formula is here. It's an improvement to the bisection method. In the bisection method, we are in fact taking uh, this next root as like this. So instead of taking the average, we are following the formula for secant line, the idea of secant line, and when we are up. Third method is known as Newton-Raphson method. Third one is known as Newton-Raphson method. So in Newton-Raphson method, you require only one initial approximation. So, but the derivative idea will come. So you have xn plus 1 is equal to xn plus 1 is equal to xn minus fn by fn dash. What is the meaning of fn? Fn is nothing but f of xn. And what is fn dash? Fn dash is nothing but you calculate by, df by dx at x is equal to xn. Then this is known as fn dash. See, this prime is here. That prime is here. So this is the Newton-Raphson method. This is the Newton-Raphson method. And now you have finally the other iterative method. See the what that iterative method says. So the fourth method which I mentioned is iterative procedure. So in such a case, see sometimes this equation can be rewritten as a x is equal to phi of x. X is equal to phi of x. In such a case, see what we are saying. In such a case, what we are saying is that, yeah. So the art is simply the approximation. Next approximation here is that is, say if you want xn plus 1 and plus 1th approximation to the root of the equation f of x is equal to 0. This is our given equation. Suppose let we are able to write like this. Implies means we suppose there are some equations which are expressible in f of x is equal to 0, which are expressible as x is equal to phi of x. So in such a case, xn plus 1 is nothing but phi of xn. Is that is known as phi of xn. So from the nth approximation, we can find like this. So this is called iterative procedure. This is called iterative procedure. So four prominent methods that are useful for obtaining numerical solution to algebraic as well as transcendental equations have we recalled. Now see something called, when I say when can we stop the process of finding better and better approximations. See, when can we stop? Once there will be a pre-specified error such that when two successive absolute value of the absolute difference between the two successive roots becomes less than the pre-specified error, then we stop the iterative process. So in such case, see that idea is known as it reaches ultimately one will reaches closer and closer to the exact root. This idea is known as convergence of the method. And so rate of convergence of bisection method is linear. It is a linearly convergent. It converges in a linear fashion. Rate of convergence of iterative method is also linear, while rate of convergence of Newton-Raphson method is quadratic, and the order of convergence of false method is 1.618. That is very important. These 4 points we need to determine. Then this is all about single equation. Then you have a system of linear equations. We have Gauss elimination method is there. Then you have Gauss-Jordan method, Kraut's method, and LU decomposition method probably might have seen. Based on this one, also we can talk about, yeah, these are the few methods that comes, numerical methods they are useful for the development of numerical methods for solving system of linear equations. Most prominent among the numerical methods among the among which applies these ideas is Gauss-Seidel method. Both Gauss-Seidel method and Jacobi's method are numerical techniques for finding approximate roots of a system of linear equations. Remember here, bisection method, regular falsi method, Newton-Raphson method, and a fixed point method or iterative method. These fixed point method, they deal with only one equation. On the other hand, when you are dealing with the system of linear equations, then you can either apply the numerical techniques or either Jacobi's method or this Gauss-Seidel method. So now we will see some important questions, some model questions on these numerical solutions to uh, algebraic and transcendental equations. So, right. So the iterative formula to find the square root of a positive real number b using the Newton-Raphson method, that's what they are asking for. So see square root of a positive real number b. See how can we get that? So what is given here? B is a positive number, positive real number. What we need to compute? We need to know x is equal. So we need to know square root of b. That is b to the power half. What is this? That is the question. So that is unknown thing. So we let in fact. So we let x is equal to b to the power half. So if we let x is equal to b power half, then x square is b. So implies x square minus b is equal to 0. Simply look for the solution here. approximate solution for x square is minus b is equal to 0. Once you determine that approximation, then it becomes an approximate root of b. So that is the idea here. So here when you want to see, if you look at, if you treat f of x as x square minus b, if we apply, see, we want to apply Newton-Raphson method. So in such a case, in such case, because derivative can easily be computed, f dash x is equal to f dash is equal to here 2x. So, by our formula, xn plus 1 is equal to xn minus fn by fn prime. So, here, okay, what is your f of x? Our f of x is, our f of x is x square minus b. So, b is given in actually. What is fn? Fn is nothing but f of xn is equal to xn square minus b. And now here, what is fn prime? Fn prime is f dash of xn. So this is nothing but 2xn, 2xn. So our formula now can be, this becomes xn minus, our fnc here is, fn is here a root, xn square minus b by 2x. Okay, so we will see this. So xk plus 1 is, yeah, you can see here xk plus b, xk plus b. See, where is this? What did I say? Xk minus. So you need to get this as xn square minus b. Oh, good. So this can further be simplified as xn minus 1 by 2 xn minus b by, I mean, this becomes b by 2 xn, b by 2 xn. So can that be simplified as this, as here? I think you cannot transform like that. So none of these may be the answer. So we'll see, go see the answer D, none of these. So that is correct. So the correct answer will be this. None of these. None of these means, see here again. None of these. This is for the first question. So the correct answer is here actually. You need to get this. That is not, you are not, we are not able to find that in the choices. So none of these is the correct one. So the second one is Newton-Raphson iteration formula for C, cube root of C, for cube root of C. So here for the next problem is you need to find cube root of C. That is, cube root means this. What is this? C, he is here. C is positive. He says we need not worry about that, strictly speaking. So we say that, we say we need to find this approximate root, say x. So if that is the case, then we have x cube minus c is equal to 0. So you can treat this as f of x is equal to 0. So our f of n becomes naturally xn cube minus c. Xn cube, and then if you want, if we want f dash of x, because for Newton-Raphson method we need to find f dash of x. F dash of x is 3x square minus, that's all, 3x square. So when it is 3x square, so we have f dash xn, 3xn square, 3xn square, right? So just a minute here, right? So how the approximate root can be found? The approximate root can be found xn plus 1 is xn, sorry, xn plus 1, xn minus fn by fn dash. So this is xn minus fn is xn cube minus c by 3xn square. This is the formula. So this is the required answer. Okay. So what it will, upon simplification, what you will get. So this is, so you have 3xn cube minus xn cube plus c by 3xn square. So this is equal to 2xn cube plus c by 3xn square. 2xn cube plus c by 3xn square. C is the correct answer. So C, for the second question, C is the correct answer. Yeah, right. Now come to the third one. Again, Newton-Raphson method. So Newton-Raphson method, you have to be, most questions may come from Newton-Raphson method formula. So you have to be careful. So Newton-Raphson, see in this case, uh, x square minus 2 is equal to 0, that is given. X square minus 2 is equal to 0 is given. So when you take this part is, f of x. This part is f of x. So to find, so what is fn? Fn is f xn. So now from this one, what is f dash x? 2x. So what is fn dash? Xn. Nothing but 2xn. Now the first approximation, see what he has given actually. Let the initial guess x0 is this, and what is the subsequent guess, that is x1. So they have given, now you need to write the formula for x1. So x, usually xn plus 1 is, the formula is fn minus fn dash. So if you want a n as say 0, so x0 is f0 by f0 dash. So that is nothing but x0 is 1.0 he has given, minus f0. F0, what is that f0? F0 is x0 square minus 2. So 1.0 whole square minus 2 by f dash 0. F dash 0 is 2 into x0. So that is 1.0. 2 into 1.0. Okay. So this is nothing but This is nothing but 1.0 minus uh, so you have plus 1 by 2. So 1.5. 1.5 for x1 is 1.5. So have we got the answer 1.5? Yeah, that is B. For the third question, the answer is B. Third question, the answer is A. They are saying there may be an error here. So, so this is right. Okay, this 1.5 is correct. When right. Right. Yeah, this is now reciprocal of A greater than 0. So there is a now how this can be done. So we need to find 1 by E. A is positive. So what is this? So what is given? A is positive here. So we take this as x. We take this as x. So x a is equal to 1. So that implies ax minus 1 is equal to 0. So what is our f of x? So our f of x is this. So our f of x is ax minus 1. So fn is fxn is axn minus 1. Then what is f dash x? F dash x is a. So what is fn dash? Prime. So this is axn minus 1. Right. So xn plus 1 is xn minus fn by fn prime. So this is xn minus fn is axn minus 1 by a. So we have that is the answer, right? Right, right, right. Okay. So the next problem. Okay. So now take this one. For example, the next one. X0 is equal to 0.2. First two iterations will be for, okay, we take the next one. So is it to see what we have done here is correct? C cube we have done. So xk plus 1 is there. So what is the Newton-Raphson algorithm for this one? So what I did here, reciprocal 1 by a is x, they need to be no. So xa is 1. So ax minus 1 is 0. So f of x is that. So fn is axn minus 1. Now f dash x is a. So fn dash is f dash of xn. Axn minus 1. Right. Okay. So, right. Okay. To the next one. Finding the square root of 2g's. Findings, oh, wait. Okay, we do here some. So, Newton-Raphson method for solving the equation x cube minus 3x plus 3x minus 7. X cube x cube plus 3x minus 7 is equal to 0. So, in this case, what is our f of x? This is our f of x. So, what is fx fn? Minus 7. So, what is f dash of x. F dash of x is 3x square plus 3. Therefore, f dash n is 3x n square plus 3. 3x n square plus 3, right. So, how this can be written? The iterative formula. Okay. So, this is the formula. Is it right? Yeah, right. Right. Okay. So, xn minus what is our fn? Fn is 3n cube plus 3n minus 7. Is it right? 3n cube plus 3n minus, sorry, xn cube plus 3xn. xn cube plus 3xn. Okay, 3xn square minus 3. Okay, this is the value. Hmm. So here, upon simplification, what it results in, if I simplify this further, I will get 3xn cube plus 3xn minus xn cube minus 3xn plus 7 by plus 3. So this is 2xn cube plus 7 plus 3. So what we got? Xn plus 1 right. This is our thing. Now see, we need calculator here. We need calculator. Yeah, right. Sorry. So yeah. So see here. What is given here? What is given? Given thing is here, right? So x0 is 1, that is given, and we need to find f of x1. We need to find next value. Next value x1. What is the next value they are asking? So x0 is 1 is given. So if you want x1 to x0 cube plus 7 by 3 into x0 square plus 1. So because our x0 is 1, it is given as x0 is 1. Yeah. So 2 plus 7 by 3 into 1 square is 1, 1 plus 1. So this is 9 by 6. So this is 3 by 2. It is 1.5. X1 is 1.5. So C will be the answer, right? It will be C, not check. It will be C. So fifth is C. Now go to the this one. Okay. So here so what they are saying, the series converges to, see, for example, for x square we have done a problem, I think. For square term, have we done? Yeah. See, what is the formula here? The formula here is xn plus 1 is equal to, right. So I'll correct from this one. Collect from this one. Okay. Xn minus what is Fn here? Fn is xn square minus 2 by, okay, 2 into xn, I think. Yeah, right. 2 into xn. So this is coming as 2xn square minus xn square is xn square plus 2 by 2xn. Okay, good. So this you can further write as xn by 2 plus 1 by xn. Okay, xn by 2 plus 1 by xn. Why I am talking about this is xn by 2 plus 1 by xn. So xn by 2 plus 1 by xn. So it is 9 by xn they are writing. So what is the answer? See, if we go for a general one, okay, I think yeah, just a minute. See, for example, I want to find kth root of 2, say kth root of 2. How can I write kth root of 2? Okay. So what it will come? So our function will be this. Okay, this is our f of x. What is f dash x then? Kx power k minus 1. Okay. So what will be our formula here? Xn minus f of xn. What is f of xn here? Right, it is xn power k minus 2 by Okay, by 2 by f dash is kx power k minus 1, kx power k minus 1. Right. So this becomes k xn power k minus x power xn power k plus 2 here by, okay, kx power kxn power k minus 1. So this further upon simplification, why I am doing this, I'll tell. K minus 1 into x power xn power k by k into xn power k minus 1. Okay, right, plus 2 by k into xn power k minus 1. I think kth root of 2 I am talking about, kth root of 2. Okay, kth root of 2, good, kth root of 2. So if we take, okay, this is further is equal to k minus 1 x power k, okay, by, no, this is not necessary. Yeah, I will tell xn, that's all, by k plus 2 by k xn power k minus 1. Okay, so now look at this formula. What is given in this? Xn by 2 plus 9 by 8 xn by 2. Okay. So what is the answer here? For sixth one, A. So here 3 by 2. He is saying 3 by 2. It is for 3 by 2. How can we say it is 3 by 2? The series convergence to x0 is 0.5 obtained from Newton-Raphson method. This problem has some issue, I think. 3, how can we say 3.5 it converges? So 3 by 2. Okay, we'll do one thing. Suppose if you want to find 3 by 2 by Newton-Raphson method. So what will happen? X is equal to 3 by 2. So 2x minus 3 is your f of x. We need to find f of x identically equal to 0. So what is f dash x? F dash x is 2. So xn plus 1 is equal to xn minus fn. Fn is 2 xn minus 3 by dash, that is 2. No, there is some problem issue is there here. Some typographic error. Okay, like this, now you can go on for similar problems here. Similar problems are there here. Okay. Okay, good. We'll take this one and we'll shift to the next one. Okay. For example, 14th problem we will take. 14th problem we will take. We will take the 14th problem. Okay. What does that 14th problem says? F of x is equal to x plus square root of x minus 3. F of x is equal to x plus square root of x minus 3. What is f dash x? 1 plus half into, okay, square root of x minus 3. This is the one. Okay. So now xn plus 1. Xn minus, okay, what is Fn? Xn plus square root of xn minus 3. By, okay, Fn prime 1 plus half, okay, this we have to write 1 plus half, oh yeah, right, this we need to write here, right. So this is the formula for that. Now what they have given is, we need not simplify it. X is 2 is given, what will be the next one? So I take x0 as 2. So then we want to write what is x1. X1 is x0 minus, we will rewrite x0 plus square root of x0 minus 3 x0 minus 3 by 1 plus 1 by 2 root x0 plus minus 3, x0 minus 3, right. So this is when x0 is 2, 2 minus 2 plus square root of 2 minus. So there is again a problem here. X0 plus x0 minus 3. Sorry here. We do one thing. We want to find root of this, right? Oh, did he say by Newton-Raphson method? Yeah, Newton-Raphson method he is saying. Because if I write 2 there, it becomes 2 minus 3 means square root of minus 1. You should not choose initial root as x is equal to 2. That is the problem again here. So you cannot choose that. He has given x as 2. You should take any initial approximation bigger than 2. Then only it works. Bigger than 2. Then only it works. Otherwise it won't work here. Otherwise it won't work, because if you take an initial approximation as something less than 3, then the square root is not defined. So there is some error in the given problem. Okay, right. Next one is bisection method. Bisection method, okay. He has given 1 and 9 as the interval. Good, okay. We'll try this. So what is our f of x in this case? F of x in this case is x power 4 minus x cube, x power 4 minus x cube plus minus x square minus 4 minus x square minus 4. That is f of x is equal to 0. He says this is equal to 0 we require. So the a and b values he is giving as 1 and 9. So a is 1, b is 9. So if you take a as 1, it is negative. If you take b as 9, okay, in such case also what is, let me see, a1, if you take a as 1, your f of x is coming as, okay, minus 3 minus 4, it is minus 7. See here, okay. So here f of a is minus 7. I want to find what is f of 9. Means 9 power 4 minus, okay, 9 cube minus 9 square minus 4. Okay, this value I need to calculate. So 9 power 4. How can I find 9 power 4? 9, 4. 9 power 4 minus 9 cube. Okay, we will do one thing. What is 9 power 4 value? This minus 9 cube. No, invalid. Okay, just a minute. 9 cube, 81 into 9. 9, 81 into 9. 729 minus 9 square, 81 minus 9, right, minus, what is that? 4. So this is 5737. This is positive, this is negative. So the root lies between these two numbers. It's okay. Now what will be the approximate root? So your initial approximate root is a plus b by 2. So 1 plus 9 by 2. So it's 5. That is the first approximation, 5. Okay. Yeah, right, it is C. The answer is C. So for 15, we'll see. 15 answer is B is saying no, it is C. There are so many errors here. 15, it is C, it is correct. 15C. Because 1 plus 9 by 2 is 5. C. Right? Okay. Uh, so like this, you can do the other problems in a similar way. Most of the problems are on Newton-Raphson method. Please take care of that. Okay. Now we'll go to numerical integration part. Numerical integration part. Right. So when you go to numerical integration part, I'll go straight to trapezoidal rule. See what in numerical integration. So what I suggest, this bisection, regular, falsy, Newton-Raphson and fixed point methods were there. Here, trapezium rule, Simpson's rule, and rarely Weddell's rule, but more focus more on trapezium and Simpson's rule. Okay, so if that is the case, see here, Simpson's one third rule is there, 3/8 rule is there. Trapezoidal rules is given by sum of the first and last terms plus 2 into sum of the remaining terms, etc. Okay, I will tell this one what we mean by. So usually when it comes to numerical integration, when it comes to numerical integration, so our see, you what is that integration means? F of x dx, you have a to b, you need to find it without with numerically using some numerical technique. So this f of x, they will give in the form of a table. What we mean by in the form of a table? So, you have x0, x1, x2, xn like this. Okay, assume that the difference between any two successive xi's is fixed and it is h. Okay, so it is equally spaced data of width h. Then, so you have here x, and then what is f of x? So f of x means here I write y0. So this is y, or I can also write f0. There is nothing wrong in writing f0. So similarly, this is y1, y2, yn. Only thing you should note is that xi plus 1 usually is same is as h. Okay, then see, come out to here. He says, right, when the data is like that, for trapezoidal rule, see what is happening here. If you have h as the common difference here, then or naturally, what will be your x0? Our x0 will be a. This is a plus h. This is a plus 2h. This is a plus nh, n into h. Now this integral value, that is this. So what it that one trapezium rule says, a to b fx dx is x0, b is x0 plus nh fx dx. This is approximately equal to, okay, see here, h by 2 into sum of the first sum and the first last 10 terms. So I'm taking here h by 2. So that is y0 plus yn. That is sum of the first and the last terms plus 2 into the remaining terms, that is y1 plus y2 yn minus 1. This is the formula. Simply you take that, you will get the answer, approximate value of the integral. That is what it says, the trapezium rule, trapezoidal rule. Similarly, if it is one third rule, you have h by 3 into sum of the first and the last terms plus 4 into sum of odd terms. Odd terms means y1 plus y5 plus etc. and plus 2 into sum of the even terms. That is for one third rule. When it comes to 3/8 rule, so you have sum of the first and the last term, 3 into sum of the remaining terms plus 2 into sum of multiples of 2. Okay, that is what we have for 3/8 rule. 3/8 rule. Now we go directly. The other rules are not that not of much importance here. They did not play much role. So now we'll do some problems on numerical integration. Do some problems on numerical integration. So yeah, let's see. So see, for the first question, the answer is, this is a standard question B. So that is 2. Simpson's rule for integration gives exact result when f of x is a polynomial of degree 2. When f of x is a polynomial of degree 2. See, for example, if you want a degree of 2, okay, that is the answer for that, right? Then the trapezoidal rule of integration gives the exact result when the integrand is a polynomial of degree. That also you better to remember. So it is B again. So for this, you have to be but one but not 0. So it's a polynomial of degree 1. The trapezoidal rule gives the exact value, while for the Simpson's rule of for integration, if it is a second degree polynomial, it gives the exact value. Okay, now come to this one. The value of integral 1 to 2 1 by x dx computed using Simpson's rule with step size h is equal to 0.25 is, okay. So right, 1 to 2 1 by x dx, 1 to 2 1 by x dx. Simpson's rules we are talking about. One to two. This we want. 1 by 2, 1 to 2. 1 by x, 1 to 2. Right. So what you need to do here? You need to, the h is given as 0.25. Is it right? H is given as 0.25. Good. So what is your starting point? Starting point is 1. So 1.00, then 1.25, then 1.50. You are adding 0.25, 1.75 and 2.00. So now for 1 by x, so you just take 1 by x value. So this is your, I am writing here, this is your x value. Now you need to write y is equal to 1 by x, because the integrand here is, 1 by x. So this is nothing but y. This is nothing but y. So in such a case, you need to calculate. So see here, this is x0, this is x1, x2, x3, x4. It is like that. Okay. Now here it is y0 is 1 by 1.00. This is y0. And 1 by 1.25 is y1. 1 by 1.50 is y2. 1 by 1.75 is y3. 1 by 2.00 is y4. Is y4. So with that, Now Simpson's rule will apply. So each of these things will simplify. This is 1 by 1.25, 1 by 1.25. How you can get 1 by 1.25? Okay, 1 by 1.25. 1.25 is 0.8. This is 0.8. 1 by 1.5. 0. I take 67. Next one is 1 by 1.75. So that is 0.57. Then 1 by 2, 0.5. Right. Now we want to apply Simpson's rule. So we'll take one third rule. You need not go for 3/8 rule. Okay. You simply go to because unless otherwise specified, you always take one third rule. For one third rule, what is the one third rule here? One third rule says that h by 3 into sum of the first and the last term, and 4 into sum of odd terms and sum of even terms. Okay, 4 to 2. So now the required integral. Okay, is equal to h by 3. H is 0.25 by 3 into first and last terms, that is y0 and y4. So 1 plus 0.5 plus 4 into odd terms. What are odd terms? 1 and 3. 1 and 3 are the odd terms. So 1 and 3, y1 is 0.80 plus the other odd term is 0.57 plus 2 into the even terms. Even term is only even term here, one and only one even term, except the end terms I am talking about. So it is y2, its y value is 0.67. So this is the value for one third rule, right? So now we will simplify this. So what is this? 1.5 plus, okay, 1.5 plus 1.5 plus in the, that is there in the parenthesis I'm talking about, 8 plus 0.57. So you have 7. So 3.8 plus 5 is 3.2. No, no. This is 8 plus 5, 13. 13. So 1.37. 4 into 1.37. 4 into 1.37. 4 into 1.37 plus 4 into 1.37. Okay, then plus. Okay, 4 into 1.37 plus 2 into 0.67. So 0.6 directly will write 4 1 point 1.37. 1.37. That is 8.35. Now 8.35 into h by 3 we have to calculate. So into h is 0.25. That we will see. Okay, right. Divided by 3. you are getting 0.6758, 6958, sorry, 0.6958. One should not write like this. It is an approximate value only. In fact, this is also an approximate value. 0.6958. That will be the correct answer. Yeah, 69 approximately. We are coming close to 6958. I think maybe one should claim the answer as D. The 6958 is close to that. Then okay, fine. Another, you always prefer uh yeah, now see 1 3. You always prefer numerical ones. That is better. What I suggest. So sixth one. Sixth problem I'm doing 1 2 3 1 by x dx. 1 2 3 1 by x dx. This is also one third rule. Okay, another problem. So this is 1 2 3 1 by x dx. This we need to find by the one third rule. So what is h is giving? Is saying h is 1. See, you can see that h is 1. Length is 1, he says. Subintervals of length is 1. H is 1. So when h is 1, okay, when h is 1, we need to prepare a table here, like in the previous problem. So we are starting from 1, then 2, then 3. That's all. So this is your x values. Okay. So then y is equal to what is that? Your 1 by x. So 1 by 1, 1 by 2, 1 by 3. So this is your x0, x1, x2. Okay. In such a case, see, let me see the problem again. Yeah, right. 1 by x, 1, 2, 3. So the step size is clearly mentioned as 1. So this is now this is y0, this is y1, this is y2. Fine. Now this approximate value. So integral 1 to 3, 1 by x dx is approximately equal to h by 3. So you have h by 3. First and last values here, that is y0 and y3 only. So here y0 plus y3, and then you have only here y0 and y2, not 3. Right, first and last values are y0 and y2. Then you have only one odd number here, subscript with subscript 1. So you need to take 4y1. That's all. There are no even things between y1 and y0 or y1 and y2. So you need not one need not collect that. So this is equal to okay. Now this value is 1. Now this value is 1. This value is 0.5. 1 by 3 means 0.33 I will take. Okay. That's okay, right? Fine. So 1 plus 0.33. So this is 1 by 3 into 1 plus 0.33 plus 4 into y1. What is that y1? Y1 is 0.5. 0.5, 4 into 0.5, sorry, it is 4 into 0.5. So this is 1 by 3 into 1.33 plus 2.0. So this is coming as 1 by 3 into 3.33, 1.11. So I hope that answer will be there. Yeah, right. It is C. C is the answer. Okay. Then similar problems only try to do most of the problems. For example, I'll take this one log x problem. If you take log x problem, that's on trapezoidal rule. That's on trapezoidal rule with five subintervals. He says, okay, fine. Two 2.5 to 4. Okay, 2.5 to 4. Our next problem. So we need to calculate 2.5 to 4. What is our x? Our x is log x dx. This is our x. This is our integrand. We need to find trapezoidal rule. This one approximate value. So trapezoidal rules 5 subintervals. Okay. So 5 subintervals means you. It is a simple thing. If you consider this as A and if you consider this as B, you do one thing. You need the number of subintervals is denoted usually by n and the step size is h. Then what is the relation between nh and a, nh, a and b? Our b minus a is equal to, I mean, b minus a. Okay, if you divide this b minus a, you need to divide that into how many parts? Nh. Good. So I write this as, okay, a plus nh, good, minus a. So this becomes nh because n subintervals we are doing. So it is nh. So our h is equal to b plus b minus a by n. H is equal to b minus a by n. That is the relation. Therefore, h is equal to b minus a by n. So now what is our b by b and a? Our b is 4, 4 minus 2.5. 4 minus 2.5 by n. N is 5 because he is staying 5 subintervals. So 2.5 means 1.5 by 5. So 0.3. This is our h, 0.3. Okay, now we prepare the table. That's the only alternative. That is the only thing we need to do. So x is x and y is log x. So 2.5, you have 2.8, you have then 0.3, 3.1, then 3.4, 3.7, 0.3 we are adding, and then 4.0. That is what. So you have here log 2.5, log 2.8, log 3.1, log 3.4, log 3.4, log 3.7, log log 4.0. They are the things. Now for trapezoidal rule, what will be the formula? Okay, I'll write that. So you have 2.5 to 4 log x dx. That is what we are thinking about. But before going for that one, what is log 2.5? You need to calculate all these things. Okay, log 2.5. Log 2.5. So logarithm means ln, I said log 2.5. Log 2.5 is 0.9 0.9163 0.9163 0.9163, right? Log 2.8, log 2.8. So we have 2.8, 2.8. So 2.8 is 1.0296. 1.0296. Log 3.1. Log 3.1. Log 3.1. What is log 3.1? 1.1314. 1.1314. Log 3.4. Log 3.4. 1.2238. Okay. Then log 3.7. So that is 1.3083. Then you have log 4.0. That is 1.3863. Okay. Now what is the trapezoidal? What does the trapezoidal rule says? By trapezoidal rule we have h by 2, last two terms sum plus 2 into that. Okay, fine. So this is equal to h by 2. H is 0.3 by 2 into, okay, last two terms. Here what are last two terms? So y0, y1, 2, 3, 4, 5. So y0 plus y5 plus 2 into the remaining terms. Y1 plus y2 plus y3 plus y4. They are the remaining terms. So how we are doing the labeling here? So this is our x0, x1, x2, x3, x4, x5. This is our y0, y1, y2, y3, y4 and y5. So last two terms 0.9163 plus 1.3863. 0.9163. So you have 0.9163 plus 0.9163 plus the last term 1.3863, 1.3863. Okay, plus you need to multiply 2 into start the middle terms. The middle terms 1.1 1.0296, 1.0296 plus 1.0296 plus 1.1314, 1.1314 plus 1.1314 plus 1.2238 plus 1.2238, 1.3083. Now the bracket close. What is this sum? 11.688. Okay, fine. What is our actual formula says? 0.3 by 2. That needs to be multiplied by 0.3 by 2. So 0.3 by 2 is, you have here 1.5, 0.15. Okay, 0.15. That needs to be multiplied by 0.15. So it gives us 1.7533. So this will be the answer. Okay. So this value is, we are I think doing some problem here. Yeah, right. No, not this. Trapezoidal root we have done. Logarithm function. Yeah, right. 1.7533. See, that is the 13th problem. We got this answer. Okay. So this is about numerical uh, algebraic solutions to, I mean, numerical solutions to algebraic equations and numerical integration. Okay. These are the topics, two topics I have covered so far. That's all for today. You can also, in fact, see similar way. Yeah, all these problems are similar ones, right?